Number 28. Why are fluoroalkanes unreactive? You either know this or you don't. The answer is that the CF bond is very strong. So if you had something that was, say, for example, an OH minus, and you're expecting it to the fluoroalkane to undergo nucleophilic substitution with the OH minus attacking the delta plus on the C and expecting the electrons to go from the CF bond onto the F and release F minus. It's just not going to happen because that bond is too strong. So your answer is D. Which alcohol could not be produced by the reduction of an aldehyde or a ketone? Well, if you think about it the other way around, then an alcohol, a tertiary alcohol, can't be oxidized by acidified potassium dichromate to form an aldehyde or a ketone. So a tertiary alcohol can't work, and the reason is that if it's a tertiary alcohol, then the carbon with the OH has got 3 other bonds attached, and therefore when it forms a double bond to an oxygen, it would have 5 bonds. Then it would have 3 carbons still bonded and a double bond to an oxygen. It would have 5 bonds. That's not possible. So if you look at it the other way around, if you had an aldehyde or a ketone, you're expecting the carbon to oxygen double bond to become an OH and the carbon to get an extra H. If it's got 3 other carbons already bonded to it and it forms an OH and an H, it's going to have 5 bonds. So another way of looking at it is that if it's got 2-methyl-butan 2-ol, if the numbers are the same, then the ol group is at carbon number 2 in the middle of a chain. There's a methyl group at carbon number 2, so that carbon number 2 has got a carbon either side and a methyl group and an OH. How could that possibly have formed that ol from a carbon to oxygen double bond? Because that carbon number 2 would have to have a carbon to oxygen double bond before it was reduced to become an OH, and it would have 3 other carbons around it. It'd have 5 bonds. It's not possible. So you're looking at this is a tertiary alcohol, couldn't be oxidized to form an aldehyde or a ketone, and vice versa, the aldehyde or a ketone couldn't be reduced to make a tertiary alcohol in the other direction.